In this section, we're going to get started with MongoDB, our database layer. By the end of this section, we're going to learn how NoSQL databases such as MongoDB work and how we're expected to architecture and model our data. From a practical point of view, we're going to fully set up a MongoDB instance and connect it to our Express backend. Our goal will be to take all of those endpoints that we've built so far and have them actually read and write data to our database. In this video, we're going to start things off with a light introduction to MongoDB and the NoSQL databases in general, and we're also going to draw a comparison between MongoDB and conventional SQL databases. So, MongoDB is a popular NoSQL database. While it is an open source technology, a company called MongoDB Incorporated does actually exist. Most of its revenue, though, comes from hosting MongoDB for customers through their cloud platform called Mongo Atlas, as well as consulting services. Now, MongoDB itself is a NoSQL database, which means it is non-relational, and it does not use the concept of tables. Instead, data is stored inside of collections of documents, with each document being saved as a binary JSON. It's fair to call MongoDB flexible, as documents within the same collection can vary and contain different fields. However, this doesn't mean that data structures are completely volatile. Schema validation can be set up to define what sort of key value pairs are permitted. MongoDB also has its own query language that makes it easy to find, filter, and aggregate data. And from version 4, it officially supports ACID transactions. This is a huge benefit over other NoSQL solutions, and it used to be one of its major downsides when compared to SQL databases. Finally, MongoDB is a very popular solution with a huge and passionate community. Working with MongoDB means being in good company, and I find that always to be an advantage. As for other comparisons, especially versus SQL databases, I would cut things short. The reasons I've listed are enough to form a strong argument for why MongoDB is a great candidate for many use cases. So with that out of the way, let's see how data inside of MongoDB would look like when we model it. Let's try and model 3 collections: users, products, and orders. So a user collection would consist of a simple object such as this one. But since MongoDB lets us be flexible, we could easily expand our users collection to support a new field, a shipping address object with fields of its own. And this would be good enough to let us support 2 functionalities of our backend: the ability to fetch a list of users or a specific user based on their ID. Things look very similar when it comes to our products collection. And since our schema can be flexible, we can support various types of fields and expected values. You can expect that t-shirts, shoes, and bags are going to have different fields, but they can all stay within our products collection. And actually expanding on this doesn't require too much work. MongoDB is very forgiving if you don't get your data schema right the first time. You can always try again, and it's easy to migrate data. Now, our orders collection is a bit trickier. An order needs to reference a user it belongs to, as well as the products that are part of that order. Here's a sample schema from an SQL database that shows what we're trying to mimic. A NoSQL database doesn't have this sort of powerful relational structure, but we can create and manage these relations on our own. MongoDB comes with its own query language that will let us write queries that look up data similar to how we expect we would write a select statement in an SQL database. So thanks to this, we can support endpoints that are a bit more complex, like this one that would find all orders belonging to a user with the given ID. And finally, another interesting problem we face is keeping track of product price. What if our user bought an item while it cost $19.99, but then the price changed to $24.99? How do we know what the price was when the order was made? This is, after all, a shopping platform, and prices get changed all the time. In SQL, it's common to have a revisions table that would also be referenced. So you would save the ID of the revision with the order, and thus know what the price was at that time. We can do that with MongoDB as well. But we can also make things a bit simpler by storing entire snapshots of the item upon purchase. Now this is what we call a clear trade-off. We're adding redundancy and taking up more memory, just for the sake of having to manage less relationships between different collections. And when you're dealing with a small number of fields, that could be a good trade-off to make. And finally, we should also keep a price history in our products collection for analytic purposes as well as for potential conflict resolution. Well, I'm sure that was a lot to take in, so feel free to rewatch this video and sketch out your own ideas on what other fields and collections we'll need for our web store. Anyway, don't worry if this is still not crystal clear. We'll go through all of this one more time when we actually implement it on our backend in this section.